Cool. Here we are. Looks like we're live. Cool. Just kind of getting set up here a little bit. All right. All right, cool. Well, thanks for joining us today. My name is Michael Walter, and we're in my basement. This is where we watch TV. This is where we hang out and do laundry. This is where the kids play sometimes. It's usually a mess. I tried to clean it up a little bit today. But yeah, going to be getting into some fun stuff today. Going to try to do like a hello world type of a thing with Go. We might, well, we will kind of get into how we can deploy Go on Lambda. So that's a goal. And then we might get into a little bit more advanced kind of stuff with using SAM, Serverless Application Model, to deploy our Go program. Yeah, we're going to poke around and look at a few fun things. This is my first time doing something like this, so please bear with me. I obviously have zero idea how to stream, but I'm going to give it a shot, and hopefully we'll have some fun. So let me start off by introducing myself a little bit, giving you a little bit of background. So my name is Michael Walter, and I am a senior solutions architect at AWS. So I actually work at AWS. I've been there for about 3 years now, a little more than 3 years, based in the New York City area. So I'm broadcasting to you here from Long Island, where I live. And I have a background in museums and art, photography, and a bunch of other stuff we can get into as we go. And at work, I work mostly with enterprise customers in the advertising and technology industry. So big corporations are my game. So I work with lots of companies going through big transformations and that sort of stuff. And I try to help them use AWS the best I can. I have a keen interest in serverless. I think serverless is pretty fun. And event-driven architecture, that kind of stuff. And lately, for the last like year or so, I've been trying to learn Go. I started learning Go, I don't know, maybe 5, 6 years ago, just poking around with it in fits and starts, and finally decided to read a book on it, take it a little more seriously, and try to learn the language as best I can, because I think it's pretty awesome. So yeah. If you're interested, I have a website, and you can go on that website and read more articles and things about what I'm up to, things I'm doing with Go and with AWS, sort of the topics I tend to write about the most. And let me switch to this desktop mode so you can see some things. So we're going to keep it pretty casual today. I'm just going to be poking around, doing stuff. Hopefully it's interesting to you all. Feel free to chime in on the chat, or yeah, I don't know what else you would do. But anyway, this is the site. You can subscribe. I don't send out too many emails, just when I have something interesting to say. But most of the time I write articles like these about how to do little things with AWS and Go. So feel free to go there and subscribe. That's probably the best way to follow me. I also have, relevant to us, I also have this organization repository thingy on GitHub. So besides my main GitHub page, if you want to learn about Go, I've been sort of chronicling all of the things I've been learning along the way for the last year or so on this GitHub organization page. So there's all sorts of repositories, things I've been working on, little projects, and like links to blog posts and other projects around the web that I think are sort of cool. So be sure to check that out. I'll put some links and things in somewhere on this platform, and then you can click on them. And, oh, wait a minute. You can't see that, can you? Hold on 1 second. That's funny. Let me fix this. So we've had our first. That's funny. Oh, why isn't it working? I have like no idea. Let me see if I can. Oh, so I got some chat here. A security engineer friend has been also pushing me to learn Go as well. They rave about it. Awesome. Yeah, it's a cool language. I need to figure out why I can't see my browser thing here. But hang on, bear with me for a moment. Let me put that over here, switch to this. Okay, let's see what's going on. All right, I wonder if I can fix this on the fly. Let's give it a try. Yes, we'll do that. And we're going to add this. Here we go. Ah, okay, I think I got it. All right, hold on. Let me just fit this to the screen. There we go. We don't need this up here. All right, that was interesting. Like I said, I've never done this before. I have no idea how Twitch works. We're just going to have some fun. Right on. Okay, so that seems to be working now. So let me just reset some things here. Okay. Cool. All right, now that we got that squared away, we can kind of continue here. So this is that page I was just talking about. It's a GitHub organization, so it's just github.com/go-mica. And there's all sorts of links on here, some repositories I've been working on. Some of the things that we're going to do today are actually on here already, so you can go and try them out yourself. So it's a good spot to go to. All right, cool. So, oh, and let me bring my picture back up here. Oops. There we go. Ah, this is funny. Oh, I see. Okay. Fun times doing this on the fly. Oops. That's not what I want to do. This one. Okay. All right, we're almost there. There we go. Nice and small. All right, I think that's better. That looks like it works. Okay, so let's get into it. I thought for today it would be fun to kind of just do like a hello world in Go. So the very basics of writing a Go program. And then see if we can get that thing to run on Lambda. So a couple things. So let me start by bringing up this site. This is the Go website. So if you're brand new to Go, this is the first place you want to go, no pun intended, to get familiar with Go. And what's nice about this site, besides the place where you download Go and install it, is that there's tons of resources, including if you click on the Learn tab, there's this tour of Go. So I highly recommend, if you've never used Go before, this is the first stop to take. Go to this Take a Tour link, and you kind of go through step by step, and you can actually run code right in here. Let's give it a try, see what happens. This is actually what we're doing in a minute. So we just did a hello world right here in the browser. So yeah, definitely take a look. It'll walk you through sort of the foundations of Go, fundamentals, that kind of stuff. It's a great way to kind of get started with Go. It's kind of where I started my journey. And there's tons of other stuff in here too. So there are links out to documents, the user guide, other kind of tutorials that you might be interested in, the documentation website, and this thing called packages here. So this is where you go to find out about all the Go packages that live out there in the world, and there's lots. So yes, you definitely need to learn about this website. This is the first stop to take. So if you haven't installed Go before, this is how you do it. It's super easy. You just go to download right there and pick out the architecture that you're using. So I'm on an older MacBook Pro, so I use this Intel link here. If you're on a newer MacBook, you might be on an Apple Silicon, so you would want to click this one or whatever the case may be for your architecture. So you just download the package, double-click to install it, and then you've got Go on your system. Once you do that, you can open up Terminal. Here's our terminal. Let me make it a little bigger. And you should be able to type Go version, and you should see that it's installed. So I know it's a little small, but there's Go version 1.21.6, and it'll tell you which architecture you're on. And this is kind of important for later. We'll talk about architectures here in a minute, but this one says Darwin/AMD 64. So that's a Mac system, and AMD 64 is an Intel processor. So that's important to know about. But you've got the Go command line tool. You can type things like Go help and get all kinds of command line help. So that is installed. So let's close this because I'm going to spend most of my time today in VS Code. So I don't know what editor you use for writing code. I really like VS Code. It's become kind of my de facto one. I think I kind of just sort of gave up on all the rest. I used to be a big Emacs person, but yeah, VS Code is pretty good, so why not? So in VS Code, I thought we would start off by just, it's to start from scratch, right? Let's just write a hello world program in Go. So I have like a bare bones VS Code installation. I'm going to open a new folder. I'm going to keep all my code in a folder called code. And yeah, let's just call it Go Hello. So Go Hello is going to be our Hello World program. All right, so here's our folder. There's nothing in it yet. And I don't have any extensions turned on at the moment. We can turn a couple on in a moment to sort of help ourselves a little bit. But just to start off with, I think this should do just fine. So first thing to do is to open the terminal and get familiar with the command line and kind of creating a Go program from scratch. So there's a command called go mod init, which will create a new module. So a module in Go, you can think of as kind of being like a project. So it's technically like a collection of other packages, which we'll get into in a few minutes here. But yeah, I like to think of it just as the project I'm working on. So we want to create a new project. So we type go mod init, and then we give it a name. We're going to call it hello, Go Hello. And what this is going to do is it's going to make a single file in my folder called go.mod. Yeah, and you can see it's very, very simple. It just says module Go Hello, and it tells you the Go version that we're currently working on right there. And this file is going to grow over time. It's going to be where all of our dependencies are tracked. So any kind of third-party dependencies we want to install are going to show up in here with the correct version. So it's kind of like if you're familiar with like Python or Node, it's like your package.json file or your requirements.txt file. It's where we sort of track all the dependencies that your project requires. For now, we don't have any, so it's just going to be an empty file. And we can close it. And so we're going to make our first Go file. We're just going to call it hello.go. Right in the root right there. And so a Go program has kind of like three major sections, I would call them, Pretty much any Go file is going to have these. So at the top you have the package definition, I think is what it's called. So you type package main. And so with Go, you can have multiple packages in your program, like I said. So within a module, you can have many packages. And the package main is sort of like the first one. It comes from like the C++ kind of era. That's where it was inspired from. So this is going to be our main program, our package. So we just define it right there like that. That's all you have to do. And then there's the second section called import. And this is where you put all those dependencies, all the different packages that this package depends on. So I'm just going to add one for now called FMT. Some people like to call this FUMPT. But the FMT, the FUMPT package, is a very popular one. Almost every Go program will use it. And this has to do with like formatting and strings and printing stuff to the screen. So it's a very well-used and well-known package. So it's a good place to start. So almost every Go program is going to use FUMPT in one way or another. And so you can write multiple lines for imports. You can also put this all in parentheses like this. So if you have lots of them, you can put it like that. Tab it over a little bit to make it look nice. But you don't have to. So since we're just doing FMT or FUMPT, we'll leave it like that for now. And then the third part of the program is the program itself. So all of your different functions that make the program do what you want it to do. And so the package main, has to at least have one function called main. And that's how you write a Go function. It's super simple, easy to read and understand, I think. All right, so let's talk about it a little bit. So we have this word func in the beginning. FUNC is how you define a function. And one second, let me just check on something. Okay, and so then you give it a name. So in this case, it's main. And this is the first function that's going to run when you run your program. But you can have many functions, all sorts of functions, whatever you want to write. Then you've got this parentheses here, and inside here is where you put your parameters. So function main is not going to have any parameters, but if you were writing another function, you might write something like Mica string. So this is a parameter called Mica, and it's of type string. You can have another one called, like, I don't know, para bool, whatever. So you write the name of the parameter and then the type that it is. And so Go is a statically typed language, which means that everything needs to describe its type. You can't just write, you can't just do that. We don't know what kind of type Mica is now. So you have to tell it what it is, and in this case, a string. All right, so in this case, we don't care though, so we're not going to have any parameters. Now you can also do returns. So if you want to return, let's say, a string, you can put your return value there. So the returns go on the right-hand side of the function. And you can have multiple returns in Go, which is kind of cool. So you make parentheses, and you can do like string error, whoops, string comma error, oops, there we go. And this is saying that you're going to return two values. You're going to return a string and an error. This is a very common return definition. And that's kind of cool because you can return the actual result that you expected to get, or if you had an error, you can return that instead. But we're not going to return anything in this case. We're just going to be printing something to the screen. All right, so let's do it. So we're going to use this FUMPT package. We're just going to write fmt dot print, and then we're going to type what we want to print. I'm just going to write hello Go, and I'm going to add a /n for a new line, and that is the whole thing. Right, so we're using the package FUMPT that we imported. We're going to use the print method from within that package, and this is what we're printing: hello Go and a new line. Super simple. So let's save that file. So now how do we run this thing? So Go is a little bit different than what you might be used to with Node and Python. in that it's a compiled language. What that means is you have to compile it before you can run it. So Python and Node will compile your code when you go and run it, like at runtime. But with Go and other languages too, like C++ or C, you actually have to compile the code first. And so to do that, we go on the command line and we can write go build. Okay, so we're building our program, and we can see in our browser over here, we created a new file called go hello, which is the binary. So if I click on this, it's going to say, no, it's a binary file. You can't open that in your text editor. And so now I can actually just run that file with this /go hello. And there we go. It worked. So it printed out hello go to the terminal. So what did we just do? We compiled this program on the command line with go build. And then we ran it with /go hello, and it worked. So here's the thing. Every time I change my code, so if I type go or hello Micah, how about hello Twitch, and I go and run that code again, it's going to say go hello go, right? It doesn't know Twitch yet because it hasn't been compiled. So this program is still referencing the previously compiled code. So we have to do a go build again. All right, so we do go build, and then we do go hello, hello Twitch. Now it works. So now it knows about this updated code since we've recompiled it. So that's kind of tedious. It gets to be a little annoying to always be building your code every time you want to try it or run it. So there's another command you can do called go run, and you just type in the file name. And what this will do is it'll compile your code and then run it for you. So do that, hello Twitch, and then I can make a change, hello, change it back to hello go, hit save, and then I just do go run, and see it's updated it. So it's recompiled my file and run it all in one command. So that's a much more convenient way to kind of operate. There's another one you might want to know about called go clean. Go clean is a cool command. It cleans up your folder. So it deletes any compiled binaries that you might have had in there. So that binary is gone now. And now if you notice, if I do another go run, it'll run again, but there's no binary showing up here because it's actually compiling my code in some other temporary folder somewhere else on my system. Cool. Okay, so we did it. We made hello world. Hello. Let's switch it back to hello Twitch, and let's run it again. Cool. Hello Twitch. We're online, live streaming. I like how close to TypeScript this looks. Yeah. So whenever you run go build, it's actually building the binary based on the system architecture. Okay, great question. I'm just going to bring this over here so I can see it. So yeah, so the system architecture is a thing with Go. So when you just type go build, it builds it based on whatever system you're currently operating within. So I'm on this, if I type go version again, you can see I'm on this Darwin AMD 64 is my architecture. So if I type go build or go run, it's going to assume that that's what I want to do. If I want to compile for a different architecture, so some other system like a Linux system or a Windows system, I have to tell it what architecture I want to do or that I want to use. So what you're going to do is type something like this. So you type go arch, and then you type, let's say, ARM64. So that's for an ARM machine. And then we're going to type go OS or goose, and let's put in Linux. And then you just type the rest of it, build, and the rest of your build command there. And what that will do is it will essentially do the exact same thing, except it's building it for ARM and Linux as the target. So if I hit return, oops, I forgot the word go. There we go. So now it's going to create a binary for me. All right, and it worked. So we can see our go hello binary is here now. But if I try and run that, let's see if it works or not. It might. Nope. Exec format error. So I built it for Linux and for ARM64, so it's not going to work because that's a different kind of architecture. And so I get this exec error. But that's a really good point because this is really handy. You can actually build for lots of different targets, including Lambda, which we're going to get to in a little while. So let's rebuild it for, actually let's do it manually. Like if we type in Darwin and AMD 64 instead. Now let's try and run it. We're back. It's working again. Okay. Hopefully that makes sense. Okay, cool. Thanks for the question. Where did you go? Where's my... Okay, cool. Yeah, you're asking because of a K3s cluster and they are running on the ARM architecture. Yeah, cool. So that's how you do it. And you can build this all into like make files and different build processes and stuff like that. Okay, so let's do a go clean. I want to show you something really handy, which is the Go extension. So if you use VS Code, there is this Go extension that you should probably consider using. And this does all kinds of fun stuff. So this will do things like you can hover over package names and get help, get links to the documentation, and it will also do things like kind of clean up your code as you go. So for example, if I'm not using the FUMT package anymore, it's going to underline me in red because Go, to compile it properly, is going to see this as a compile error, right? So if I save this file, it disappears. So it automatically cleans up your compile errors for you. And likewise, if I type FUMT print, you can see all the different flavors of print will show up. Type ahead, and I'm going to put in the same hello Twitch line, and you can see the FUMT part is now underlined red because it says undefined. This is a compiler error too. But rather than typing in the import, I can just type save the file, and it will automatically put the import up here for me. So that's just a handy thing to know about. But the type ahead thing is great too. So if I do FUMT dot, you can see all the different functions that live within that package. So printf, print line, sprint or sprint, same kind of category of functions there. Error f, all sorts of stuff. The FUMT package is pretty helpful. All right, cool. So I think it should still work. Let's do go run. Hello. Yep, and let's do a go clean up that binary. Awesome. All right, so that is hello Go. So I mentioned make files a little bit, so let me explain what that looks like. So it's pretty common practice to set up a make file for your Go program. So you can create a new file called makefile. Makefiles are basically like scripts that work in your terminal, and they do what you tell it to. So they can compile your program in whatever way you want it to. I'm going to do like a really simple one here. I'm just going to give it a hello makefile, and I'm going to say go build, and I'm going to put -o for output, and bin/hello, and then the name of the file, hello.go. So I'm creating a command here that's going to build my program, hello.go, but it's going to put it in the bin folder, which I don't have yet, and it's going to call it hello. So rather than calling it go hello, it's just going to call it hello. And so make files are very handy because you can kind of like script what you want them to do, basically. And you can just type make hello, and it will do it. So it created a bin directory, and it created that hello binary, and now I can type ./bin/hello, and it works. So there's my program in the bin folder. Bin folder is a common place to keep your binaries. So that's cool. I don't wonder if the go clean command still works when you have a folder. No, it didn't do anything. Interesting. Okay, well anyway, so that's a make file. So that's a really handy way to compile your programs. And as you see, you'll see as we go that they come in handy when you're doing things like deploying to Lambda or other kinds of things on AWS. Cool. All right, let's see if there's any other stuff going on here. Okay, looks pretty good. All right. So let's switch gears a little bit. Let's talk about AWS Lambda for a moment. So we're going to jump out of this VS Code editor. And before I do that, if you're like new to AWS, yeah, there's a lot we can say about how to create an account, how to set things up the first time. I use this app called Leap or Leap. I don't really know how to pronounce it, but it's a really handy tool. So if you're going to go through the process of using AWS all the time, using things like single sign-on, or if you work at a company where that's already put in place for you, this tool is really handy because it will automatically log you into stuff. It'll create temporary credentials on your system, so you don't have to go into the command line and like modify your credentials every time. It'll automatically do it for you. You can see here I've got a bunch of AWS accounts underneath one organization. So I've got a new one here called Twitch. And so I can just click play, and that will automatically put my credentials on my system for me using temporary credentials that expire after a certain amount of time. And it will also let me easily jump into the console. So I just logged into the console just like that. Super slick. So I would definitely check out Leap. I think it also works with Azure and maybe other cloud providers, but I find it super handy. Okay, cool. So we are in the console. So this is AWS. AWS is a lot of things. So if you click on services, there's tons of services. There's like hundreds of services here. So it can get a little overwhelming at first if you've never used it. There's a search bar up here, which is really handy. So if you're looking for a particular service like Lambda, you can just type it in here and it should pop up. And that's how you can navigate around the console really easily. What is Lambda? Lambda is AWS's serverless functions as a service kind of thing. So you can create functions. They can be written in a multitude of languages, and they can be invoked by all sorts of different events. They're serverless, so there's no like underlying servers that you have to worry about. And it's billed by the millisecond. I think that's right, millisecond. So it comes with a bunch of free invocations, so you can kind of do quite a bit with Lambda without paying for anything. So it's really great for building backends, building interfaces into your databases, all sorts of stuff like that, or building batch processes. Yeah, it's a pretty flexible system and lots of fun to play with. So you can see I've already got some other function in here. This is from Control Tower that I use to provision this account. When you start, you probably will see 0 functions in here. And then over here on the left, there's a couple other links to know about. So there's this dashboard link. I'm zoomed in big time here so you can kind of see stuff. So it doesn't ordinarily look like this. But this is a sort of dashboard that tells you what your current concurrency is, as well as how many functions you have. And if you scroll down a bit, you'll see things like different metrics, how many errors you've had recently, how many invocations you had for all of your different Lambda functions, what your current concurrency looks like, all sorts of stuff. So it's a handy page to go to. If you go back to the functions page, you can create a function. So let's do that. All right, so this is the create function page. Let me just grab this, okay. So there's 3 ways to create a function in the console. You can make one from scratch, so that's what we're going to do in a little bit. You can use a blueprint. So a blueprint is like a template to kind of like get you started. You can also use a container image. So if you like containers, that's another way to deploy a Lambda function. Just for fun, let's do a blueprint. So if I click blueprint, I can scroll down here, and here's a Node.js blueprint. If I click here, there's a whole bunch of different blueprints to play with. There's actually quite a lot. They're almost all Python and Node examples, but that's okay. So let's do a Node hello world blueprint. So I'm going to call this hello Node. And you can see it's already picked out a runtime. So that's the Node.js runtime, and an architecture. So it's using Intel architecture versus AMD. It's also going to create for us something called an execution role. I'll talk a little bit more about that when we get into it, but basically this is the permissions that allows Lambda to do other things. So to talk to other services across AWS for you. You can pick an existing one. We don't have any yet, so we're going to create a new role with some basic permissions, it says. Then you can actually, in this template, you can plug in some code right in here. So you can actually type in sort of a boilerplate code before you even create the function. So this is a Node program that's going to print some logs, it looks like, and some values. So super simple, kind of like a hello world for Node. So we're going to create that function, and we're just going to wait for a moment while that happens. Cool. All right, so it worked. We have a function. It's written in Node. I know that's not what we're here to talk about, but just to kind of figure out what's happening, I'll give you a little tour of Lambda. Why not? Okay, so yeah, so up at the top here, there's kind of like an overview. So you see your function here. You'll see any kind of triggers you have and any destinations you create. It'll give you like the ARN, which is a sort of a identifier within Amazon or AWS. And then down here is where all the fun stuff is. So you've got a code editor, so you can actually go in here and type code and edit it right within this console. You can browse the different files right here as well, so it's super helpful. You have a test tab, so you can create different kinds of test scenarios based on different kinds of events that you might want to trigger your Lambda with. This one is a super simple JSON payload that's got a few different keys and then corresponding values. There's also a place to monitor your function, so you can look at what all the invocations and errors for that particular function. And then, importantly, there's this configuration tab. So this is where you create all the different configuration settings. So in this case, we've got a 128 megabyte memory allocated. We have our timeout set to 3 seconds. We have some ephemeral storage. You can click on the permissions tab here. Here's that role that we created when we created the function. And looks like it has access to CloudWatch logs. And that's about it. But you can also put in things like environment variables. So if you've got, you know, I don't know, like an API key or something like that, you might want to define that in here. And all sorts of other stuff. So this is where all the configuration goes. There's quite a lot of stuff you can do. You can configure your Lambda to do for you. I'm going to skip over this other stuff here for now because it's a little bit more advanced. But let's try and test this function. Let's just see if it works. So I'm going to go to the test panel here. I'm going to run this test. Okay, it's green already, so that was fast. And so when it turns green, that means we had a successful test. We can open this panel and see the details. Let's close this guy here. So we can see that it returned this value 1 statement. It gives us some information about how long it ran for. So it ran for 6.7 milliseconds. It had an init duration of 180.09 milliseconds, and we were billed for 7 milliseconds. It tells you a little bit about the memory consumed, 66 megabytes, and then down here you get some logs. So this is actually the CloudWatch logs that will pop up in your CloudWatch area of AWS, but they're just in here as a handy place to look at them. And so you can see it printed out what you told it to. So it printed out this loading function piece. It printed out each of the values. These are just console logs that were written in the code. And then at the end, you get this report thing. And this is kind of important. This tells you all about what you just did in that invocation of Lambda. So that's this whole overview we just went over in your logs. And so you can use this to kind of see how much memory you're using up, how long your function is taking to run, and things like cold starts and that sort of thing. So it worked. Let's do it again. Why not? Let's test it again. Okay. This time, what happened? It ran for 86 milliseconds. We were billed for 87 milliseconds. It used about the same amount of memory. But what happened to init duration thing? The init duration that was taking its time is gone. So the first time we ran the Lambda, it had this thing I mentioned called a cold start. And a cold start is the Lambda kind of provisioning what is called an execution environment for you. And the second time it ran, it didn't need to do that because it's already created that same execution environment, so it's basically reusing that execution environment. And so, yeah, that's a thing to think about. Cold starts take a little bit of time on the first invocation, and then they go away. And then your execution environment lasts for a certain amount of time before it gets recycled, and you get a cold start again. That's kind of the sort of the process Lambda goes through. So at first, it doesn't really matter, but eventually, when you get into building a program that is being used all the time, cold starts are definitely important things to think about. All right, cool. So we made a node function, but that's not what we're really here to do. So let me close this. And let's open up VS Code again. All right. And we're going to make a new, let's make a new folder. Okay, so let's call this go hello Lambda. Let's open that. And so we're going to do kind of the same process we did for the first hello world function. Okay, so we're going to do our go mod init, and this time we're going to call it go hello Lambda. So same thing, it's just going to create this go mod file, and nothing in it yet, but we called it something slightly different, go hello Lambda. All right, so let's recreate our hello world function here real quickly. Let's call it same thing, hello. Let's call it hello Lambda this time. .go. And so same thing, we're going to type package main at the top. We're going to import funct. We're going to make a function main, and we are going to print hello go /n. Okay, cool. Same program, good to go, and we can run that program. Go run hello lambda.go. Okay, so it still works. This is the same exact program we made before, but it's not going to work on Lambda, and there's a couple reasons why, actually. So first of all, it's built on the wrong architecture. So if we do go build, right, this binary is made for my Mac, and Lambda runs on the Linux operating system. It also is, you can pick on Lambda which architecture you want to use. You can use Intel architecture or AMD. So yeah, we haven't mentioned that in the go build process. So yeah, this is definitely not going to run. But there's another reason this is not going to run on Lambda, and that's because we haven't built what's called a handler in our code. And so Lambda needs a way to like connect with our function. And the way we do that across pretty much all languages is by this thing called a handler. So we make another function. We can call it whatever we want. I'm just going to call it handler for now. And for this one, we're going to return, let's do this. Let's return a string and an error. And so the way this is going to work with Go is we're actually going to kick off this handler with a special function here in a moment, which I'll show you here in a second. And the handler is what's going to actually get run in your execution environment and do all the things that you want it to do. So to do that, we're going to use a package called AWS Lambda Go. Let me just grab that real quick. One sec. Okay. Okay, so let me just grab this from here. So we're going to add another import, and since we have two imports, I'm going to do it like this. Oops. Okay, and so you'll see this is a third-party package. It's not a core package like Fumpt, which is built into Go. It's actually something built by somebody else that's living out on GitHub. So it's built by us, by AWS, and it's called AWS Lambda Go, and it has this /lambda folder directory, essentially. And so this is a package that gives us a bunch of functionality for building Lambda functions with Go. And the way this works is we just have to create a single line here, lambda.start, and we have to tell it what the name of our handler is. So we just type the word handler. And then rather than putting the print statement in the main program, we can put it in the handler. But we are supposed to return stuff, right? So either a string or an error. Actually, we have to return both. The way Go works, you have to return both things. So we're going to type return, and we're going to basically return the same thing here as a string. So we're just going to return it just like this. And then we're going to put comma nil because we don't have an error, or at least we hope we don't. So we have to return both parameters. So we're returning a string, and then we're returning nil as the error. So we're just saying there was no error, basically. Okay, so if we try and run this on our machine, what's going to happen? Let's try go run hello lambda. We get some errors. Okay, so first of all, we don't have that package on our system. So we need to do this line here called go get, and then the name of the package. So that's another thing to know about. If you want to use a third-party package, you have to kind of install it on your system, and you can use the go get command line to do that. So if we type go get and then put in the URL to the package, it should work. So it says, yeah, so it's worked. Okay, and now, interestingly, if we click on go mod, we can see it's added this package as a required statement. So again, sort of similar to package.json or requirements.txt in Python, keeping track of our dependencies. There's another command you should really know about called go mod tidy. And go mod tidy will clean up that file, so it took off some comments there. And it will also, if you've created other imports across your program, it'll make sure that they're all in here in your go mod file. You'll notice it also created this go.sum file. You never really have to touch this. This is like, I don't really know how to describe it. It's kind of like your package.json lock file, I guess, is a good analogy. And you can see there's a bunch of dependencies within the Lambda dependency. So we have this AWS Lambda Go dependency, and then there's all this other stuff that the Lambda package looks like it probably depends on it as well. Okay, enough of that. So maybe we can run it now. Let's try it now. So go run hello Lambda. Okay, we got an error. So it's a different error. It ran, but we got an error about the environment variables. It's looking for these two AWS Lambda runtime environment variable things. So okay, yeah, we're not on Lambda, right? We're on my Mac here. So we can't actually run this program locally anymore. It's not really designed for that because the first thing we're telling it to do is to kick off this Lambda handler. And my machine doesn't really know how to make sense of that. So the next thing we can do is we can upload it to AWS and see if we can run it there. And so to do that, we have to build it for AWS. So first of all, let's clean up our binaries here and create a makefile. So let's make a new file called makefile. And no, I don't want to install the extension for that just yet. That's okay. And let me just bring up my notes. Okay, so I'm just going to copy and paste this from my notes. Make things go a little quicker. All right, so I'm going to make a makefile. It's going to have one declaration here called Lambda. You can put whatever you want here, really. And here's the command. So I am going to say use this ARM64 architecture. We're going to build for Linux. We are going to add a tag called Lambda no RPC. I can get into that later on, but basically, because of the way we're going to deploy this, we can eliminate some sort of build dependencies. And then we're going to call it a special thing. So we are going to call it Bootstrap rather than just like hello Lambda. And this is important. In order to deploy Lambda functions on AWS that are built in Go, we need to call the program Bootstrap. And I'll explain why and how this works once we get in there. Okay, and then we have a second line, which is just to zip up our file. So we're going to deploy our Lambda with a zip file. There's other ways to deploy a Lambda function. Zip is probably the most simplest thing to do. So I'm going to type make Lambda. Okay, so it's compiling my program for Lambda for that architecture ARM64 and for Linux, and it's saving it as a file called Bootstrap, and it's creating a zip file with Bootstrap in it, basically. So if I look in my bin folder, there it is. There's my binary called Bootstrap, and there's my zip file that contains the Bootstrap binary. That's what I'm going to upload here to Lambda. All right, just going to check in if there's any questions. No, there's no questions. Okay, cool. So we're going to move on. So I'm going to go back to Leap, and I'm going to open up my console again. And it's in the wrong place. That's okay. And let's actually close VS Code here for a moment so it's a little bit more clear. So I'm going to go back to Lambda, and I'm going to create a new function. So I still have my hello node function here that I made, but this time I'm going to create a new function, and this time I'm going to author from scratch. So I'm going to make my own function. Let's call it go hello Lambda. Okay, but it's not going to be a node project. It's going to be a Go project, but there's no Go here, is there? Okay, so here's the deal. There used to be Go. You used to be able to pick the runtime called Go, but we recently made a change, which is that rather than using the different Go runtime that you can pick here from the list, we're using what's known as Amazon Linux 2023 or provided .al 2023. And this thing can run any OS, so it's sort of agnostic to what kind of code you're building. But it doesn't come like pre-packaged with all the runtime stuff that you might find here. So it's a little bit more appropriate for compiled languages like C++ or Go or Rust, or anything custom. So you can actually run like PHP on here, all sorts of stuff. So we're going to pick that. Okay, and so here's that message. So when you use this, when you use Amazon Linux 2023 as your runtime, you've got to name your script or executable Bootstrap. And so that's what we did, and that's why we did it in VS Code. And then when I'm going to pick my architecture, I chose to use ARM64. So we got to make sure we click that correctly. Execution role, so same thing again, we're going to create a new execution role with basic Lambda permissions. Now I could use that existing role I just created for my other Lambda, but I like to create a new one for each thing. It really depends on your sort of design preferences. So we're going to create a new role, same permissions. I'm not going to do any advanced settings. So we're going to create that function. And there's going to be a couple little important differences when you're using Go on Lambda. And at first, in my opinion, they're a little bit unfortunate, but as you'll see, it's okay. It's all good. So yeah, so we successfully created our function, so we can close this green banner. So same thing, we've got our Lambda function overview here. And then there's a code editor, but Lambda doesn't, this environment we're in here doesn't really support Go. Remember, we're on that Amazon Linux 2023 runtime. So you can run shell scripts and things, but that's about it. So you'll see once we upload our code, this will kind of go away. But everything else is pretty much the same. So we've got a ARM-based Lambda, and we're going to upload our code from a zip file. So you just go here, upload from, click zip file. You can also upload to S3. So if you have a larger Lambda code base, you might want to use S3. So you upload your code to S3, and then you use this interface to connect to it. But we're just doing a little hello world, so it should be fine. So we click upload. Then we have to go and find our code. So here's my code folder, here's my bin folder, and there's that bootstrap.zip file. All right, so we're just going to click that. Super easy, and click save. You can see it was about 4 megabytes, if you notice that. So 4 megabytes is decent for a Hello World program. But if you go over 10 megabytes, you're going to start wanting to use S3 or other means. All right, so it's been updated. So we've uploaded our code, and now you can see that code editor has gone away because this particular type of function, it says here it's too large to enable inline code editing, but also it's written in Go, and we don't have the Go compiler on provided AL 2023. But everything else is the same. It gives you information about the size of the code. It tells you your runtime settings, Amazon Linux 2023, your architecture, ARM64. And then there's this piece here, handler. hello.handler. So if we run this right now, it's not going to work because we made kind of a boilerplate Lambda function. We need to edit this and tell it what the name of our handler actually is. And for Go programs, you just type bootstrap. Okay, so we click Save. All right, and so now, hopefully, if we did everything right, we should be able to test this. So we're just going to use that same test event, although we're not really going to be playing with this payload. It'll just get lost in the ether. So we're just going to run a test, and we got some success, so that's a good sign. If we go into the details here, we can see it returned hello Go. Yay, it worked. All right, so we successfully built a Lambda function in Go on our desktop. We packaged it for Lambda, we uploaded it to a new function on Lambda, and we ran it, and it worked. So it returned hello Go /n. And you can see all the information. So there was a cold start of 36 milliseconds, so actually a little bit less than our node cold start. It ran for 1.59 milliseconds, and we were billed for 39 milliseconds. It used 14 megabytes of memory. And here's our logs. So it printed out hello Go, and then it gave us a report. So when you do let me bring up the code so you can see what we're talking about. So in Go, when you do a print statement, so that funct print hello Go, that will get printed to your logs. So that's handy, right? So if you are building a program and you're trying to debug it and figure out what's going on, you can use this to write some log data, and that will wind up in AWS in your CloudWatch logs. But you can also see it right here. And again, you get that report, tells you what happened. So let's run it again. Okay, that was super fast. All right, so it ran again. This time it only took 1.94 milliseconds, so we were billed for 2 milliseconds. No cold start involved here. 15 megabytes of memory consumed. Nice. All right, so we've got, what do we have? We have a Lambda built in Go, and it's working. Kind of awesome, I think. But that was a pretty, like, in my opinion, kind of a painful developer experience. Because think about what we had to do. We had to build our code on our desktop. There was really no way to test it there. And so we just had to kind of compile it there for Lambda, upload it to Lambda, test it there. I can see this being really problematic if you're trying to build anything besides Hello World, because every time you make a mistake or you want to test your code, you've got to go back and forth between your local environment where you can't test anything and your Lambda environment where you can. So that's kind of a bummer. So there is an answer, and the answer is the Serverless Application Model, also known as SAM. So let me bring up that website. So one sec. Okay, so SAM is two things. It's pretty cool. SAM is a tool, it's a command line tool that helps you deploy your serverless projects to AWS. So you can do all your deployment from your local environment, like your desktop. And it's also a way to define those projects. So it's a template system. So you create a template file, you put in what you want. So you have a Lambda function that you want to create, you can define that right in the template. All right, before we do that, let's jump back to our code editor here. And I'll kind of show you how this works. So let's close this for now. So first of all, we're going to go to our extensions and turn on the AWS Toolkit. This thing is cool. I definitely recommend it if you're doing anything on AWS to install the toolkit. It does all kinds of things. But for now, it's going to give us some pretty cool functionality around building our serverless application. So I just turned it on. You'll see there now that there's an AWS tab on your VS Code. And you can use this for a number of things. So Amazon Q, which is in preview, is on here. This is our Gen AI chatbot. So that's kind of cool. I can show you that in a minute. Code Whisperer is like a Gen AI-based coding assistant, also pretty cool. And then you can explore your AWS account. So we can actually look. So we can go and see our CloudWatch logs. And hey, there's our Lambda that we just ran right here. Go hello Lambda. And we can actually look at our CloudWatch logs right here in VS Code. Isn't that cool? That's awesome. So I don't have to go into the AWS console. I can just click on this and see the most recent log. So there's those 2 invocations we just did in the console. They're showing up here in our VS Code environment. So that's kind of helpful as well. Ooh, and lots of other things. So let's do this. Let's go back to our folder here, and this time we're going to create a new file called template.yml. So YML is short for YAML, and this is like a really easy to read, human readable kind of format you've probably run into at some point. And this is how we define our project. So we use what's called the Serverless Application Model, also known as SAM. So as I mentioned before, you have to install SAM. So there's SAM version. You can see make sure that it's installed. You're also going to need the AWS CLI. I already have that installed on my system, but that's another thing you're going to want to install. And that will let you do things like AWS S3, LS, list my buckets. I don't have any buckets. That's cool. Okay, anyways, you'll need those 2 command line programs. So the AWS CLI and the SAM CLI, and you can get those off the AWS website. All right, so here's the deal. You can type out YAML to define your project, but there's a really cool feature that just came out recently where I can open this with a tool called Application Composer. All right, so this is going to take a second to pop up, and it's zoomed in like crazy, so it's going to look a little funky. Application Composer, right in my VS Code, gives me a way to build my serverless application in a visual way. So what are we doing? We're making a Lambda function, right? So we type Lambda, there it is. So I drag this over to my workspace here, and now I've got a Lambda function defined. Okay, that's cool. Let's give it a name. Let's call it hello go function, something a little bit different than what we deployed in the console. All right, so let's go through this. So we're going to use same thing. Package type is going to be a zip, but our source code is going to be in a different spot. Let's call it. All right, we're going to fix this in a minute. Let's keep it like this. Hello go function. It's going to be a folder. And we're going to pick our runtime. So we're not doing Node.js. We're doing provided AL 2023. So we pick that. And what's our architecture? We're using ARM64. And our handler, again, is going to be Bootstrap. Everything else is the same. Let's dial this down. We don't need 3,000 megabytes of memory. Let's do 128. Timeout 30 seconds, that's fine. All this other stuff we can leave as is for the moment. Let's click Save. Okay, so what did that do? Well, it created all of this stuff for us in our template.yaml file. So it just makes things easier, right? It just writes this code for you. So you can see this is what a SAM template looks like at a very basic level. So this is our hello go function. It's a serverless function. We have a little description. Here's the code URI, handler Bootstrap, Here's our runtime, our memory, our timeout. We've got X-ray tracing turned on, that's cool, our architecture, and we're going to create a log group as well. And I'm going to add one more thing that's not here called metadata. And I'm going to put in, I think, build method. Yeah, and instead of using makefile, we're going to put in go1.x. So this is just going to tell SAM we would like to use the Go command line on our system to build our code before we upload it to AWS. So a couple other things real quick. So we're putting our code in the source directory now into a folder called hello Go function. So in source, so it created a source folder for us, and it put some node things in here for some reason. So let's delete that, and let's make a new folder. Oops, that's okay. Hello Go function, and we're going to put that in the source folder, and we're going to move just this part, the hello Lambda code, in there. We're going to keep our mod file and our make file all in the root, but inside this source hello Go function folder is where our hello lambda.go program is. All right. So what do we have to do next? So I think we have everything else right. So we're going to open our terminal, and we are going to do something called SAM build and see what happens. All right, it's doing stuff. It build succeeded. Okay, cool. Okay, so it has, let's take a look at what it did. It built our function. It created a folder called .aws-sam. And if you look in there, there's our build, there's our function, and it's called Bootstrap. Look at that. It might have actually worked. So it's still on our local system, so now we're going to do this thing called SAM deploy guided. Guided will just give us some prompts that should help us. So we can give our application a name. So we're going to call this Go Hello Lambda is the name of our application. We're going to put it into US East 1, same region we were in before in the console. Yes, we want to confirm changes. Yes, we want it to create roles for us. No, we're not going to disable rollback. Yes, we're going to save our configuration to a file. That's basically it. All right, so let's see what this does. Okay, so it's doing something, hopefully. What it's supposed to be doing is communicating with AWS, and what SAM actually does behind the scenes is it creates a CloudFormation template. And that CloudFormation template on AWS is what manages our code. So it's an infrastructure as code service. And SAM basically just makes CloudFormation easier. So it gives you a bunch of tools on the command line, and it simplifies the template and that kind of thing. So yeah, SAM is awesome. All right, so it's creating the required resources. So the first time you do this, it can take a couple of minutes. So I will take a sip of my drink. All right, so, oh, SAM looks pretty neat. It is. Yes, you're right. It is pretty neat. It's definitely a handy tool. Okay, so it's doing stuff. Awesome. It's doing all sorts of things. What it's doing is it created an S3 bucket for us, and it's uploading our function to S3 and the template that we created as well. And it's going to use that S3 bucket with CloudFormation to actually do all of our deployment. And here it's telling us what it wants to do. So it wants to add our function itself. So a new Lambda function. It's going to create a new role for us with the right permissions that we want. And it's going to create a new log group as well. So we can track the logs for this specific function. So let's do it. Yes. All right, so now you'll start to see some output here as we deploy our function. So it's creating, this is straight from CloudFormation feedback. And you can actually go into the console and see this happening there as well. But we'll just give it a minute. Okay, it is completed making the role, it's completed making the function. That's cool. It completed making the log group, and it's done. All right, let's go see what it did. So if I go back to AWS, all right, here's the console. I'm going to jump into Lambda. And now I have 4 functions. Okay, so I've got my hello node function. I've got this one that I had from Control Tower. I have my hello Lambda function I made manually. And now I've got this new one called go hello Lambda, hello go function, and a bunch of gobbledygook. And so this is the function that I just created in SAM and deployed from the command line. So I can go in here and I can do the same thing. I can test my code right here. I can test my function just like I did before, but we don't have to. This is what's really nice about SAM, is that now I can do this command called SAM. Well, 2 things. I can do it remotely on AWS, so I can say SAM invoke. Let's do a help on that. SAM invoke help. No command called SAM invoke. Oops. I forgot how to do it. Let's see. So we can do a local invoke for one thing. So that means we can actually run it right here on our machine locally. I think you can actually, where is it? Maybe not. That's fine. I was wrong. Anyway, let's do a local invoke. So we can do SAM local invoke. And you can give it like the function name, or you can just, since we only have one function, we can just type that. And this is interesting. What it's going to do is it's actually using Docker, which I have installed on my machine, I think. Yep, it is installed. It's going to pull down an emulation image for provided Amazon Linux 2023. It's going to build that image. It's going to compile my code, and it ran it. Look, hello go. So we actually ran this locally right here on the machine. So this is super nice because now, remember I was talking earlier about how painful of an experience you can have kind of uploading your code and testing it. Now we can actually go and make changes. So let's say, let's write a little code here. So rather than that, let's make a string called this. Oops. Hold on. Okay. And then let's do funct message, funct print message. So we're going to print this out, same as before. And then we're going to replace this as well with message. We're going to return message. Now we can just change this to Twitch again. Nice. Okay, so now basically the same thing, except we update the string in one place. Okay, so now if we do SAM build, and it should go a lot faster now since we built it already. And now we can do SAM local invoke again. And there we go, hello Twitch. So we can actually test locally. And we haven't pushed this to AWS yet. So if we want to push it to AWS, we just do SAM deploy. This time we don't need the guided part since we already did that. It's going to look for any changes. It's going to roll this all up into a new asset, upload it to our S3 bucket, and here it's going to tell us if there's anything new to worry about. So let's see what it does. Okay, awesome. So we're going to modify the hello go function, right? Because that's what we just did. So if we type yes, deploy this change set, this is going to take a minute. It's going to update our Lambda function using CloudFormation. Okay. And it's done. So now I can go to my AWS console. Let's go back to here. Here's our function. And let's do a little refresh. And we can see it was updated 27 seconds ago. So we just did that. So we can go here. And let's test it in AWS. So we can test it locally. We can also test it here on AWS. And it ran. And look, it says hello Twitch. Yay, it worked. Okay. So we're almost out of time for today. We've got a few more minutes. I just want to wrap up kind of like what we did, because we did a lot in an hour and a half, and I'm getting tired. So now we can basically build our Go program on our local machine. So we can work here, right? We can change our code, and we can start building our Lambda function. And we can use SAM to deploy it up to AWS, but we can also use SAM to locally test our code without actually uploading anywhere. Right? So there it is, and it tells you some similar kind of information. You see all the logs, just like you would on AWS. You see each log message right here. Hello Twitch. You see the report with the duration and the memory used and all that stuff, and then the hello Twitch return thing there. Super cool. Okay, so that is basically it. We got through building a hello world function in Go. Then we turned it into a Lambda function in Go. Then we deployed it with SAM. And then that's basically the whole thing. So that was super fun. I think maybe next time we'll build something for real that's more than hello world. Maybe some kind of project that I can come up with, and we'll just sort of hack and see where things go. No pun intended, again. But yeah, thank you all for hanging out with me for a little bit, and looking forward to next time. All right. All right, take care, everyone.